Okay, so this is a demonstration how differently reactance of a solenoid is with its core inserted versus with its core not inserted. This is a dishwasher solenoid, and this is its core right here, sometimes known as the plunger. So with this core inserted, the reactance of this solenoid is much higher, thus the current is much lower. So I'm going to go ahead and turn this on. And don't try this at home because this has 120 volts applied to it and is only for qualified technicians. It is not recommended that anybody do this. This is just a demonstration. We got 0.66 amps right here, 124.6 volts. So we got 0.66 amps. We got 124.5 volts approximately. All right, now without the core, it's going to be much greater because the impedance of this solenoid is much lower, so much more current will flow through it. It's not going to react, and it's not going to reduce the current as much as it would with the core in it. So go ahead and turn it on, and we've got 2.75 amps. It's a big difference. Okay, so the power, or the amount of heat that this has to dissipate, or how much heat output this has, is directly related to the current. And the I've measured this at 37 ohms. This is a resistive portion of this solenoid. A simplified equivalent circuit of an inductor is its inductive portion, and then its resistive portion. There's an inductive reactance, but we don't really care about that right now. We just know that its overall impedance, we'll be able to tell what its overall impedance is by taking this 124 volts divided by the 0.66 amps, and that'll give us our overall impedance, which is 189 ohms, which is its Z impedance. Okay, and the amount of power that this core has to dissipate is going to be the I squared times the actual resistive portion. So the I is 0.66, so we got power is equal to 0.66 squared times the resistive portion, or 37 ohms. This is the power with the core in. Okay, so that's I squared R. So we got 16 watts. So that's how much heat this has to dissipate right here in its normal mode. Now without the core in it, we got 2.75 amps. All right, so that's just going to be different. P with the core out is equal to 2.75 squared times the 37. And that's equal to 280 watts. That's 280 watts. So you got 280 watts divided by 16 watts. So it's 17.5 times greater power, or 1,650% greater amount of power that this has to dissipate without the core in it. And that can result in things like this happening. If the core does not insert, that can result in things such as this right here happening. Right there, and then this doesn't come out, it's stuck. See, that's stuck. So this is one of the things that can happen to a solenoid that overheats. And certainly if it's dissipating 1,650% more power here with the core out, the core for some reason doesn't insert, it's going to burn that solenoid up. That's it for this video. I hope you found it interesting and informative. If so, please give it a thumbs up and subscribe to this channel.